Welcome to another video explaining the universe using the particle model. My name is Bobby Hilster and I am your particle model guru. Today's video is a continuation of explaining my book, Gravity is Not Free. Part 2 of the book is about me, and in particular we're going to talk about the speed of gravity. The book is divided into 4 parts. I've already covered part 1 with Dave. We're in the process here of doing part 2, and I'm going to skip 3 and jump to 4 later. But today we're going to talk about the speed of gravity. The first one I talked about was the experiment that Dr. Karazani suggested we do to show that gravity was a pushing force. Today it's the speed of gravity. The next one in this series will be about Measusrements experiments and the calculations done. Well, going back in time, around 1665 or so, Newton develops his gravity equation with the understanding that the speed of gravity is known as, quote, instantaneous action at a distance, meaning it's fast, very fast. And of course, they also believe that the speed of light was very fast. And so you can go all the way up to the year 2002, and people are still believing that it is very fast. Tom Van Flander, as an author of a paper in a chapter in the book Pushing Gravity, and he has this whole chapter, and he talks about several things, but in particular on page 106 he lists 8 different analysis that he did, most of them having to do with cosmological events and so on. And he concludes at the end that the speed of gravity is at least 2 times 10 to the 20th times c, like infinitely fast. And this book was published. I don't know when Tom did the work, but the book was published in 2002. So even up to that point, people thought gravity was virtually infinite. Well, then in 2008, I am involved with the gravity. I've done the experiment with David and so on. And it was the middle of the night, and I was awake thinking about the 3 anomalies. But today I'm going to briefly talk. I'm going to talk about the LA anomalies that happened in 1954 and 1959. In general, scientists were worried about how strange they were. And they are strange. You would not have expected this to happen. But then I realized, thinking about them, that there's something else that's there that people are ignoring, and it's the timeline. Well, it was in June 1954 that the anomaly was first reported as an anomalous precession of the plane of oscillation of the Foucault pendulum during a solar eclipse, June 30th, 1954. Now, he's talking about the plane of the pendulum, and the pendulum basically stays, if I could say it, stays in the same plane. Let me do it this way, back and forth. The pendulum itself doesn't move. The Earth moves below it, and when we're standing on the Earth, moving with the Earth moves counterclockwise. The pendulum appears that it's moving clockwise, but it's not moving at all. He went on to win the Nobel Prize in Economics, not for this. He just apparently worked in economics as well. Well, this was the measurement, and here you have the angle that the plane of the pendulum was at, very close to 180, which I would expect, if 0 is east, I would expect this might be west. It was pointing west at this point and slowly moving uh, in that direction to east, slowly moving it. It's moving to the east, just like we are. We move to the east as we go through the earth. Well, and here's the hours that local time. So this was morning, and they were tracking and keeping track of the position of the plane when the eclipse started. You saw the eclipse. When you see the moon and the sun touch, the pendulum jumped backwards. It was moving this direction. It jumped back instantly. And then it goes on to go, it moves further and further back, then slides down quickly. Why it does all these strange things and all that. And it ends up here. This straight line is what it should have followed had there been no eclipse. Notice it ends up like there was no eclipse at all. But everybody's worried about this, and I'm saying, no. You're forgetting. It's not. Yeah, we need to explain that too, but there's also the timeline. What is this telling me? Especially right here, that the gravitational effect on the pendulum happened at the same time the visual effect happened. They happen from the same time, and they're caused by the sun and the moon. And it ends here at the same time. The maximum here was not 100%. This was not 100% eclipse. There were these two of them. One was in the 30% range, another was in the 60% range. So they weren't 100%, but he still had this effect. Visual effect and gravitational effect appear on the surface of the Earth at the same time. That's what that timeline tells me. Well, on October of 1959, he did it again, and he reported another observation of the effect during a solar eclipse of October 2nd, 1959, using a paraconical pendulum he invented. And this study earned him the 1959 Galabert Prize of the French Astronautical Society and made him a laureate of the U.S. Gravity Research Foundation for his 1959 memoir on gravity. So this is an actual picture of Maurice Allais and his paraconical pendulum. Well, the thing that was unique about the paraconical pendulum was it wasn't that it was just hung on a hook. He had this precision, looks like a precision stainless steel ring made, and inside the ring it was a brass unit, cylinder with a ball at the end, and in this plate there's a socket, so he has a ball and socket. So now the pendulum can swing back and forth in the plane, but it can also twist the other direction. Not only go this way, but twist the other way. So it gave him total freedom in all directions. And this is the 1959 measurements. And again, we're starting at an angle. It's not at 180 degrees this time, but it's 195 moving this direction. And again, the visual effect of the eclipse and the gravitational change caused by seen by the motion of the pendulum happen at the same time. The effect of the gravity and the light appear at the surface of the Earth at the same time. If they're propagating from the sun at the same time and takes that long, then they must both be moving at the same time. And of course, by this time, we already knew that the speed of light wasn't infinite, that it was the speed c. Well, to solidify the whole thing, I had come to my own conclusion based on the timeline. Then there was a Chinese paper written in 2012 about the observational evidences for the speed of gravity based on the Earth tide by Ki Young Tong and others. This is the introductory paragraph to his paper. We have found that the current practical Newtonian formula for the gravity tide of the Earth, there's a formula for the gravity tide of the Earth, implies a hypothesis that gravity travels at the speed of light. Furthermore, we have derived and solved the propagation equation of gravity using the observation of data of Earth tides from Sequani and Wuxi. After correction of a phase lag due to the anelasticity of the Earth, we found that the speed of gravity are from 0.93 to 1.05 times the speed of light. So they use data from these, I assume these are names of people, and they used the formula and came up to that conclusion. This provides the first set of strong evidence to show that the speed of gravity is the same as the speed of light. Well, in April of 2015, I came up with my idea for light as a particle, using a light being a stream of particle. I've covered this before. Each particle in the stream is moving at or about speed c, and the stream has a repetitive pattern, a peak, a valley, a peak. This is David's sine wave generated stream of particles. And then I used that stream of particles and I applied it to refraction. And when I did, and I concluded that there could be a second gravity, which I started to call gravity 2, because then I had gravity 1 for Newtonian gravity, and this is clearly not Newtonian gravity. Gravity 2, which we now call we morphed it into the G2 particle, and that it bent the light when it refracted. The G2 particle must be faster than light and smaller than the G1, and I've covered some of those issues in other videos. Well, it wasn't long after that we had this kind of going now, really starting to do the particle model. This is really beginning of the particle model, and this part is not in my book. I have a piece of it, some of this that I've just said in my book, but then it stops. These things now happen in our book called Hacking, Universe Hacking. Okay, so David is, we're talking and he questions me. He says, first he makes a few statements. He says, gravity particles come from the stars. Light as particles come from the stars. They both have a speed about c. Are they the same particle? Well, yeah, okay, it makes sense that they could be the same particle. Two particles moving at the same speed and moving through the same medium must be similar in nature. Identical, no proof, but it led us to think that it's possible that they're the same particle, coming from the same stars, moving at the same speed, moving through the same medium. He continues, he says, what about the electron? The particle model assumes the electron has no charge. So if the electron had a charge, a gravity particle and light particle probably would not have. So, but because it has no charge, it opens the question, David's question. The electron, of course, drifts at the slow rate of 3.2 meters per second. But the signal, the current, and the wave fronts move from 50% to 99% of c. And my conclusion is that if it moves at c at all in the first place, in any condition, it's probably moving at c anyway, and there's a different reason for it to appear to move slower because of the path it takes. Question again, is it the same particle? The electron, or which we now call the G1, moves through an RF transmitter, and I use the RF transmitter as an example because it ties both the current flowing through the circuit and the signal, RF signal, leaving the antenna on a one-to-one basis. So the electron, G1, moves through an RF transmitter circuit at speed c, and then exit the antenna at speed c as an RF signal. The pattern in the circuit and the pattern of the signal using the pattern particle model for that is identical. The pattern's identical. Yeah, maybe the G1 is the electron. Well, as time went on, I covered, it took about a 2-year period to initially cover these, maybe more because chemistry and biology didn't come until recently. G1 particle moves at speed c as a gravity particle, as a stream of particles with a repetitive pattern light, as an intensity stream, a high intensity stream of particles around and through a magnet. Worked on that. As lightning, G1 as lightning causes the spark that we see, the sound, the crack of the lightning and the spark that we hear. As an electron in the circuit, but now the G1 flows through a circuit more like water through a water hose. As an RF signal, or in general, any EM radiation. G1 is all of these things, and all of these are controlled by G2 gravity while the G1 moves through open space. Now, you can clearly understand the particle being through as gravity through an open space, and light through a magnet. Yeah, there's a lot of open space in a magnet, and the G1 is guided through the magnet. And through the circuit, yeah, through a copper wire, it's guided through the copper wire by the G2. And they're all moving, in principle, through open space. Well, this is so the end of, there are 14 chapters. I've covered these, this and this. My next one's going to be the Majorana experiments and the calculations I did using that experiment. My name is Bob D. Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.